I'm from a technology background first and foremost. My primary degree is in computer science, my PhD is in machine learning. But I've ended up kind of drifting towards kind of product management roles as I've gone through my career. Or at the moment, my title is principal engineer at Intercom, but I also sort of have ended up product managing our AnswerBot product. And I think there's something interesting there that I sort of want to talk about today, which is that, you know, when working in academia and sort of trying to build very abstract algorithms, you really have very different considerations than you do in industry, and people end up with shipping kind of much simpler things in industry, and the technology really bleeds into the product development and product management aspects of things. Something I should tell you all about me today. I'm actually a little bit sick at the moment. I've just recovering from a flu for the last 3 days. So if you see me start to sweat up here on stage or something like that, that's why. I've still got a little bit of a temperature. If I say anything that's completely off the wall, feel free to kind of stop and pull me up on it. It's probably the fever bleeding through. About you, so I'd love to make this talk interactive. I have maybe 15 or 20 minutes of material if I was to kind of run through it really fast. But I really worry about that if I do that, I won't pitch this right for the audience. Because, you know, there's a lot of people interested in machine learning and machine learning products, but people are coming from very different backgrounds because it's sort of such a new and exciting field. So I'd love to just kind of like get a couple of quick straw polls of the audience. And I presume everybody here is at least interested in Python, and I presume mostly from sort of a programming background. I mean, can you sort of raise your hands if you're sort of working maybe as a software engineer or a function close to that? Okay, pretty universal. Can you raise your hands if you are working in sort of a data role or an analytics role or anything? Okay, a lot of people, wow. And I think you can sort of see that almost in the topics for PyCon here. I have a PyCon Ireland 13 bag here on the table with me, which has been across several continents. And then I did a talk at like PyCon 11 where I actually, in Ireland, where I did kind of an intro to machine learning, and there was much less of an intersection there. So I think the communities are sort of are bleeding together a little bit, which is pretty interesting. So I'm working for a company called Intercom at the moment. Intercom, people may not have heard of them. We make this sort of business messenger, one of these things that kind of shows up in the corner of a screen, and you can click on that and open a messenger like anything you see, like WhatsApp, and talk to people and ask maybe a customer support problem. And this talk on pragmatic machine learning product development, this talk really started out live where I was trying to talk about my experience with some pitfalls of machine learning products. But rather than try and give a talk about pitfalls and things that kind of go wrong and strategies to make projects go right, I want to kind of talk about a product we built in Intercom, which is called AnswerBot, kind of as a concrete case study. But like I said, you know, I want to make this a little bit more choose your own adventure and interactive. So a genuine offer, if people have kind of things that they find interesting as they're going through, and feel free to just put up your hand and ask questions at any point during it, or ask me to kind of to drill down on anything in a bit more detail. The advice that I have here, the learnings I have here are the context they apply to are people building machine learning software products, and explicitly not mega projects, and not something where, you know, someone's willing to invest tens or hundreds of millions of dollars to crack some machine learning algorithm, and the only thing that makes sense is proof of concept, and with a very well-defined goal up front. And the reason, I guess, that motivates this talk is that I sometimes have chats with people about building machine learning products and what's required to build and ship a successful machine learning product. And papers like this, or sort of thoughts like this from some of the very big players like Google and IBM come up, where people talk a lot about what they think is required to build and ship machine learning products. And they talk a lot about maturity models and readiness scores. And they sort of say, look, if you want to build a machine learning product, You need to think a lot about like scalability up front. You need to think a lot about tech debt and how you're going to manage that in your machine learning product. You need to think a lot about you know, monitoring and debugging your system in production and your features, and will your features drift over time. And these are legitimate concerns for kind of maintaining very large, very sophisticated products. But most of the time, most products I've worked on, we don't have those problems. Our problem is even to get to that point. And so I think that different strategies apply, and I'm going to talk a little about those strategies here. So I'm going to talk a little about AnswerBot. AnswerBot's a machine learning product that we built in Intercom. And AnswerBot essentially it sits in this context of the Intercom messenger we talked about here. It's a natural language processing product. And what it does here, the idea is that an end user can come along and can ask a business, one of our customers, a question, and that we have this NLP system that will basically match that question to a known question that this bot, this chatbot, knows how to answer. And then the bot will then say, okay, did that help you, or do you need additional help, and kind of react accordingly. So that was AnswerBot. We set out to build it. We set out to build it to kind of automate drudgery, to stop our customers having to answer the same kind of 80-20% of questions again and again, and to help them kind of scale support, right? To help them be able to answer more questions over time with fewer people. There was many risks when we started building AnswerBot. The first risk that we had to manage was the risk of the end user experience. So the actual people who came and who talked to this bot. Would they like it or would they hate it? Intercom is a very design-centric, user experience-centric company. And there was very real risk there. And I guess this is the first thing I want to talk about, because I think this is a very important part of machine learning products that I often see neglected. People tend to focus on the technology because the technology is so interesting. But there's a huge interplay between the technology you should use and you can use and kind of the end user experience. And I want to kind of give an example. Excuse me for a second. I want to give an example that possibly a lot of us are familiar with here to kind of to explain what I mean about sort of this interplay between the design and the machine learning. So this is the Google Android keyboard, which probably a lot of us are familiar with. And there's a little machine learning product here, which I speculate is pretty sophisticated, right? Which is there's these kind of suggested quick replies, right? And so as you start typing with the keyboard, you get these kind of like autocomplete quick replies just above the keyboard. We're probably all familiar with this. But what I want to draw your attention to here is that someone has spent a lot of time and design effort to make these quick replies subtle, but not too subtle, right? So if these are irrelevant to you, they're pretty easy to ignore. They don't kind of like flash up and like they don't have a little card on them that says, hey, look at me, look at me. But if they are relevant to you, they can still kind of catch your eye enough to kind of be like, oh yeah, there's something there, I should click on that to autocomplete. That's a pretty fine balance there. And that design balance influences the false positive rate that you should calibrate your suggestions on, right? So like when you've got your engine that makes your suggestions, you've got a certain like kind of response curve there that you can use to like decide whether you should suggest anything at all, what suggestions you should make. And the design of the user experience kind of influences how costly it is when like a bad suggestion appears in terms of how much it distracts the user. And so instantly you can see that there's an interplay there between these pretty subtle, pretty human-centric design elements and the type of machine learning system you can build. And the more you can build a system where a false positive, like a bad suggestion, doesn't really hurt you because it can sort of be ignored, the more you can do that, then the easier it is to build a successful machine learning product. When we started building AnswerBot, we were going to have this bot that would interject itself into a conversation. And we were like, how costly is it when this bot comes in when it shouldn't? How costly is a false positive there? And that was a major risk we were carrying heading into the project. Another piece of risk, which is much easier to understand perhaps, is technology risk. And we knew this NLP tech was getting good, but we weren't sure how good it was and how easy it would be to build. And a final big piece of risk for Intercom as a SaaS business, we have a very large number of customers. We have tens of thousands of customers. Would they be able to set this up? We couldn't go and configure this bot for each customer. That wasn't feasible in our business model. So like, it's one thing to try and build a chatbot, but it's another thing to build a tool to enable people who are perhaps, less technical to build chatbots themselves. So the strategy, and I think the key thing I would say to anyone engaged in machine learning, not from a research point of view, but anyone from a machine learning applications point of view is that what you got to set out to do is to find the path that kind of cheaply reduces these risks in a balanced fashion. You don't want to go and spend 6 months building technology and iterating your technology before you start thinking about the user experience. You don't want to spend 6 months building and de-risking a great design and a great user experience and then discover that you can't quite build the technology to the accuracy level you need to make that user experience work. There's a really big interplay here. And, I think my thesis, maybe I'm wrong, but I sort of think 5 or 10 years that won't be controversial. But what we're seeing at the moment, we're seeing a lot of people starting machine learning projects, and they build a very technical team, and that team goes and focuses on technology. There's sort of a deployment team somewhere else, a team of data scientists or machine learning experts. There's a deployment team somewhere else, and the two don't kind of work closely enough in concert. And I would really say that, a huge part of trying to make a machine learning product successful is to figure out exactly the challenge you want to break off, to try and structure the challenge in a way that it's likely to be successful. That's almost the key thing. So how are we doing so far? Is this resonating? Is this kind of interesting topic or not so much? Okay, actually some nodding heads. All right, thank you. I appreciate that. I appreciate the feedback. Yeah, so I thought maybe I would talk through the timeline of how we actually built the AnswerBot product. Yep, okay, cool. All right, so AnswerBot, we started in November 2017 with some really early, really scrappy prototyping, and we shipped in October 2018. By the time we shipped, there was a lot of people working on this. I don't even know how many. There might have been 20 or 30 people across Intercom in a range of functions. That includes marketing and stuff, like the non-core development functions. So, but it started off very small and very light, and I think that's great. I'd encourage everyone to do that. It started off with a range of prototyping, initially just me, and then very soon afterwards one engineer. And the first prototype for this that we ever built was just a Jupyter notebook that ran on a single machine where we just used regular expressions and a simple Python state machine. And we built it in 1 week, and we showed it to stakeholders. And anyone who's ever written a bot for fun in a college project or anything like that probably looked very, very like this underneath the hood. And why even do that? We could show this to stakeholders, and you reduce a certain kind of risk when someone says, like, and people at Intercom were like, hey, can we start experimenting with some bots and playing with some bots? And to be able to go back in a week and say, is this kind of what you mean? Sit down and look at this notebook. You can kind of like type in queries to it and it'll reply to you. Does this resonate at all? That's valuable. And even though everyone knows you can do something like that, it reduces some risk. Prototype 2, another kind of week later, just created like 20 things the bot could say by hand, finite state machine, and added in a search engine, the Whoosh search engine, if anyone's ever used it. It's a standalone little Python library that implements some kind of standard search techniques. And we were like, can we build a bot that just uses a search engine technique, right? Like, so off-the-shelf information retrieval, BM25, if anyone's familiar with that. And the bot has a whole range of things it could say, and each query you ask the bot, you just consider it a query to the search engine. So we were like, can we get away with building no machine learning for this product entirely, using entirely off-the-shelf tech, just a search engine? And a lot of bots out there in the world, a lot of chatbots are built like that. And then the kind of risk there is like, how's the UX feel 2 weeks in? Prototype 3, about 3 weeks in. A single EC2 instance, running Python backend, no scalability, no 6 months setting up a Spark cluster and making it good or worried about robustness or anything like that. Actually got this really simple prototype bot live in the actual Intercom messenger running on an internal test site. And really thinking about the end user experience here. And this is what it looked like at this super early point, right? And you can sort of see all the sort of like the missing functionality here, right? It's like the bot's kind of saying, was this helpful, yes or no? And we knew eventually we kind of wanted buttons or something there, but at that time that was a super early kind of medium fidelity prototype. And the cool thing about that is, we could demo things like that to like the design people in Intercom, to other stakeholders, and get alignment there. And it's so easy to go and sink a whole ton of time in technology and discover like, oh, this is just not what the people that are really important stakeholders kind of think about. And I guess there's another piece of advice there I would say for machine learning products is to, there's always stakeholders. Any project has got stakeholders. There's always stakeholders. People have a lot of high expectations of machine learning projects, and so like it's really important to like kind of flush out sort of stakeholder expectations like really early on to make sure people don't want some crazy high accuracy bar before they're willing to ship something. So maybe 4 weeks into the project, it looked like this. It could run on internally in Intercom. And everything built super low fidelity, everything hacked underneath the hood. Intercom is predominantly a Ruby shop. Like the vast majority of the engineering org runs Ruby and is very opinionated about that, wants to try and kind of support minimum thing in production, minimum number of different languages in production to allow engineers to kind of move across the org easily. We did everything in Python with this. We hacked and kind of worked in our own code base, and I think that's a great way to start a new project. But by building everything at sort of a very breadth first, very kind of low fidelity version of each part of the product, we managed to kind of like hone in on the challenging part of building a bot for us, which was to try and figure out what's this bot going to say. We really quickly realized that would be what we believed was the limiting factor. And so we thought, gosh, a lot of Intercom customers have a ton of historical data. They have a ton of examples of where people have come and asked questions of them in the past. And so we started to prototype a tool that would enable people to kind of to cluster historical questions. So this is an example of this really early tool knocked up in JavaScript, where questions people have asked all appear in clustered groups over there on the left-hand side of the screen, and you can use this to sort of to configure the bot and tell it what to do. So remember, the project started in the end of November, and by February, we had a customer, a version of this that actually talked to people who came to Intercom's customer support team and asked us questions. And so, we kind of put that in front of hundreds of interactions, and we learned a lot doing that. And we learned that, end users seemed happy. The bot, it could be ignored when it came. Like they were happy to ignore it. It seemed when it came in and, asked, tried to answer their question once and didn't get it right, which it sometimes didn't. We learned that curation and setting up questions is a very iterative process. We had set out to build everything using search engine technology. Search engine technology will always tend to return, it just ranks the documents by whatever is the best match. And so it's got no sense of like saying, hey, there's no match that's good here. And so we decided to like force our customers to manually say which keywords have to be present for an answer to kind of to fire. And that was dangerous. We almost got in a lot of trouble. Some product magic. It was amazing to see the bot perfectly answer a question. And using historical questions and setting up the bot just was great. People could really set up the bot with historical data. Project moved into full production in April, answering single questions. And so, you know, I've highlighted that in bold to remind myself that we built a bot and we set it up to just answer individual single questions. So this is a product that was designed to not dialogue, not do any conversational state management. Its job is just to come in, try and answer a single question. And you can ask it for more answers, and but we very much chose a very limited canvas to operate on. That turned out to be a really good decision because it simplified things and enabled us to move faster. We were carrying risks at that point. We had that risk of false positives. The search tech we were using, there was no way of, you didn't get a well-calibrated probability score about like, this is like 70% likely to help or 60% likely to help. And we were worried about the setup experience. So yeah, moved to beta, built a really nice interface for people to curate the product. However, as I said, to control false positives, we kind of required our users to add in keywords that almost destroyed the entire product development lifecycle, or delayed it by months. Because no matter how much our designers struggled, we couldn't build an interface where people could really get their heads around keyword creation. Customers just not quite in this space enough to kind of really get that. Tons of different variations. There's a known risk, and we started a machine learning product then to develop our own scoring system using much more modern techniques. And there's ways in which that was a little bit scary, because now our machine learning project, we're doing pretty novel machine learning, but the entire project now depended on it. On the other hand, at least we weren't wasting our time doing novel machine learning that was never going to be used. So it's a double-edged sword there. I would kind of say it's good if you can to use off-the-shelf stuff until it breaks. And that's when you go and you start doing something a little bit more custom. We had this other problem of a blank canvas, right? And so we did a bunch of work, built our own kind of clustering algorithm to cluster sets of questions together, and kind of find archetypal questions that we would then suggest, hey customer, these are your top 10 questions, and you should curate answers to those. And that kind of appeared in the product in that form there. And so again, another team, a lot of work underneath the hood, a lot of complex algorithms. Can't put them in front of customers, scope it down, simplest possible interface, and that's kind of what we ended up with. Launch, beta felt good, give a ton of customers their answers, good metrics, worked well, still descoped. Because my key points, machine learning products are always risky, so it's really good to try and balance that product and technology risk. I'd always say start prototyping as soon as possible with minimal machine learning. Don't go deep into machine learning until you really validated that someone wants what you're building. Test with all your different types of users as soon as possible. Rapid prototyping, like we've learned in software development traditionally, still applies in machine learning. Expectation management's super important. The scariest thing I think a stakeholder can say in a machine learning project is, this version is not quite good enough to ship yet, but I'm sure it will be. And that just really scares me, because it's you never know what the person you're dealing with expectations are of how good the machine learning will get. And if it's not ready to ship yet, it's where is that line? So you want to find something that you can ship with the worst possible ML, and then iterate after shipping something. And yeah, and there's this huge interplay between the machine learning system and the product envelope. One sort of optimistic thought I would say is that the technology is way ahead of application here. We have tons and tons of great ML tech now, and we're just looking for product places to build them, and there's a ton of work in there. Okay, 5-minute warning. This is actually the end of my presentation. If there are questions, I would love to kind of take questions. This didn't end up being nearly as interactive as I'd hoped, because I think I'm a little bit sick, so I'm taking longer to get through the material than I would want. But we have 5 minutes. Question, yes. Cool. Okay, so questions about false positive rates, and I guess 2 questions. 1, do we monitor them? And 2, I guess, do we measure them in production and see if our ML is valid? So So the first thing is you got to detect. Okay, how do you detect a false positive, right? So like when the bot comes in and it gave something irrelevant, and so we spent a lot of time thinking about this problem. And so when AnswerBot comes in, it gives you an answer, and then it has sort of a hard-coded part of the user interface that we don't, at least at present, allow our customers to control, which is where the end user can say either, hey bot, that helped, or they can say, no, I want to wait for the team. And so if the user says that helped, then that's kind of a known good signal, right? It's a ground truth signal. An actual end user has said, yeah, that helped. However, end users don't do that often because, they have more to train the bot. So, that's a great signal, but it's too high of a bar to require as a ground truth. So we also measure times when we built this flow in AnswerBot where if the bot says, did that help? And the end user says nothing else, after maybe 3 minutes, the bot will say again, hey, look, I'm basically going to close this conversation now unless you tell me this didn't help. And then if the end user doesn't say anything else, the bot will kind of close the conversation and count that as another type of resolution. So we basically have this idea of a hard resolution when the user definitely says it helps, and a soft resolution when they don't ask for additional help from a human. And so we can use this sort of measure of hard resolution and soft resolution to triangulate kind of good performance of the product. And so we measure that in production, and we see very good correlations between hard and soft resolutions across all our customers, which show us that, the fact that soft resolutions correlate with hard resolutions consistently across customers shows none of our customers are really using this to build a kind of a bad time-wasting deflection machine, which is great. And so we do measure that in production. We measure it on a per-customer basis. And our best estimates based on this data are that our machine learning system is pretty well calibrated across customers. And customers get on average about a 30% resolution rate. So, 60% of the time when the bot comes in, the end user still asks a follow-on question. A lot of that time might be because they had multiple questions. Cool. Other questions? Okay, so on evaluating whether to use machine learning or hard coding something, what's the decision-making process? If you think there's any chance you can get away with hard coding something, you hard code it initially, and then try and ship your product in some beta form, and then see what happens. Because, it's almost always better to move from a hard-coded system that's delivering 80% of the value to a machine learning system to capture that next 20%. Or maybe you discover you don't need to. You move on, find another more fruitful place to ship your machine learning. Okay, we are over time, I'm afraid. If anyone wants to catch me out first. Look, thanks very much. Really appreciate it. Great audience. Thank you.